Yes, the recording got enabled. A very good afternoon to everyone. Today we are going to demonstrate the experiment number 6A, 6B, 7A, 7B that we have done earlier in mobile app. Okay, now in this session we are going to explain the same program, but here we will be going to take the data from external RAM memory. Fine. So where we have assumed the data when we are using that mobile app the last week, where we have kept the data either in internal RAM or external RAM memory. Kindly reply the previous lab session where the data was located. Yes, it was located in the internal RAM memory. Fine. The actual experiment we usually do is we will get two data from the external RAM memory and we will add up the two data. We will store back to the external RAM only. Fine. But here, due to you peoples not having, some of you peoples not having laptop or PC, so we planned to do that experiment in Android app. Unfortunately, that mobile app doesn't support the access of external RAM memory. Fine. But our MCU 8015 IDE software is going to support the access of data from external RAM memory. Fine. The same concept we are going to use, but the data is from external RAM. That is the only difference. Okay, fine. So now I will get into the slides. If the slides is visible in both classes, kindly respond in chat. Yes, okay, fine. Thank you. So addition of two 8-bit data. So here we are assuming that the data are from external RAM memory. Fine. Am I clear? Am I clear? Yes. Okay. Fine. So addition of two 8-bit data we are going to perform, but the data is available in the external RAM memory location. What about the size of address to point the external RAM memory location? External RAM memory அப்படின்னு சொல்லிட்டாலே அதோட size என்ன வரணும் நமக்கு? What is the possible size? What is the maximum memory you can address? Yeah, 16-bit address. So what is the maximum possible size of memory, external memory can be interfaced? Danya, the internal memory is 4 KB. What you are telling is ROM memory. Fine. I am speaking about the external data memory. Yes, very good, Anthony Surya. 64 KB. Yes, very good, Sajid. 16-bit address of 64 KB memory locations. Correct? Okay. So here in the problem statement, we are having two data X and Y. The first data, technically we call it as organ. The second data, technically we call it as add-in. So we have to consider that the data X, which is present in the external RAM memory location 8100, and the add-in Y is present in the memory location 8101 in the external RAM. Fine. So after performing the addition of two data, where the result has to be stored, sum and carry must get stored in 8102 to 8103. Kindly take a screenshot of this slide. So this is the problem statement for which we are going to write the program. Yes. Shall I proceed? Yes. Okay, fine. So with 16-bit special function register can be used to point the external RAM memory. It's very, very important. Yes. Very good, super. Dixon, very good. Anthony Surya, very good. DPTR register we have to go with. Yes, very good, Sajish. DPTR register. Fine. Okay. So we have to know what are all the 8051 instruction involved in this particular experiment. Okay, what operation it is going to do. That's very, very important. So to transfer immediate 16-bit address to data pointer register. Obviously, we have told 16-bit data. Okay, but here, as I am telling, DPTR is going to point the external RAM memory. Here, the content of DPTR going to be considered as address. Okay, that's why it is mentioned here as a address. Is it clear? Okay, what about the instruction we have to use? In data pointer register, we have to put a 16-bit value, immediate value. Okay, I will ask you some questions. What about the size of DPTR register? I think Sajesh provided the partial correct answer. Yes, 16-bit. Okay, whether the DPTR register is physically 16-bit or it is made up of two 8-bit registers. Yes, two 8-bit register. What are the two 8-bit registers? Yes, I'm waiting for your reply. The answer is correct. What are the two 8-bit registers? Commonly we call it as DPTR. Yes, DPH and DPL. Very good, very good, super. Okay, fine. Okay, very good. Where it is located? Whether it is located within the controller or it is a memory available outside the controller. I think Anthony Surya typed the correct instruction. Okay, but I will ask you some basic question. Where it is located actually? Internal memory. That means for performing an internal data transfer, an immediate 16-bit value, I have to put in DPTR register. Fine. So that's why we have to use the instruction as typed by Anthony Surya. Yes. Any guess in the second classroom? Any guess in the second classroom? What about the instruction? Sajesh, your answer is partially correct. Say immediate data. Karthikeyan, no. We have discussed. Yes, very good, Sajesh. We have to use hash. Whenever I say immediate data, we have to use hash symbol before the information. Correct? So move DPTR comma hash data 16. That is the correct thing. Fine. Okay. Now to transfer an 8-bit data from the external RAM memory to accumulator. What about the instruction we have to use? Obviously, data pointer is going to point the external RAM memory. From that, we have to get the data to accumulator register. Yes, for that, what we have to do? Move X, very good. Move X. What about the remaining part? Move X. The destination is accumulator. Very good, Dixon. Move X. A comma at DPTR. Shivakumar, kindly correct it. Hash data nama poda mudiyadu. Fine. We cannot able to put immediate data from. See, you are getting the data pointed by DPTR in the external RAM. Correct. So at symbol we have to use. Okay, fine. So move X A comma at DPTR. What about to do the reverse thing from accumulator to external RAM memory? What about the reverse thing we have to do? From accumulator, we have to put the data pointed by DPTR. Yes, very good. Move X at DPTR comma A. Very good. Okay. In the very first instruction, hash data 16 I have told, it is marked in blue color. It represents an immediate data. Fine. Okay. What about the instruction used to increment the DPTR register? What about the instruction we have to use to increment the DPTR register? Yes, I'm waiting for your reply. Yes, very good, Shivakumar. INC we have to use. So INC followed by the register name DPTR. Very good. INC DPTR is the correct answer. Okay, fine. Now, to exchange the content of accumulator with B register, which instruction we have to use? Yes, I want to exchange the content between accumulator and B register. What about the instruction we have to use? Very good, Danya. Very good. XCH space A comma B. XCHD varakudadu Dixon. It will exchange only the lower nibble between the two data. Fine. XCHD is the correct answer. Okay. Regarding this particular instruction, XCH A comma B, whether you have any specific instruction in the output sheet. What about the actual format of this instruction? Any guess? XCH A comma direct. Very good. Okay, whenever I use some other register than accumulator, okay, some other register than accumulator, its address has to be assembled. Okay, when we are assembling the program, the address of that particular register should be replaced. That is going to be a direct address. Fine. Okay. The last instruction, I want to test the condition of carry flag and jump to an address. Okay. The condition what I am going to check is carry equal to 0. That means no carry. So what about the instruction we have to use? Yes. I think second class only for Sajis I am handling the course. I think so. First class ஒரு 4-5 பேராவது ரிப்ளை பண்றோம். செகண்ட் கிளாஸ்ல யாருமே ரிப்ளை பண்றது இல்ல. சஜீஷ் மட்டும் தான் எல்லாத்துக்கும் ஆன்சர் பண்ணிருக்காரு. சாட் ரெஃபர் பண்ணி பாருங்க எல்லாரும். It's not a good thing. Okay, what about the instruction? In first classroom they have typed the answer. What about the response in second classroom? Quick. I have to test the condition of carry. Okay, what about the condition I have to test? Jump, no carry. So what about the instruction I have to use? Kindly respond. Yes, very good. J and C. Here in 8051, all the conditional instruction uses which type of addressing range? Relative or longer or absolute? Which one? Relative. So what should follow after J and C? An 8-bit offset value, correct? An 8-bit relative offset value. So what about the instruction? Very good. J and C, an offset value that we are representing it as REL. So that's all about the prerequisite questions. If you people understand the answer for these questions, you can easily write the program. Okay, now we are going to get into the program part. So this is the logic we are going to use. So as usual, we have to get the organ from the external RAM memory. We have to get the addend from the external RAM memory. We have to perform the addition. We have to store the sum and the carry in the external RAM memory. Stop program execution. That's all. Okay. At the beginning of the program, I will use one assembler directive. What is that? From where my program should get assembled. What about the assembler command we have to give? Yes. Very good, Anthony Surya. We have to use the assembler directive org. So org 0000H. Fine. Okay. Now I want to take the data from external RAM memory 8100. Am I right? There only my argument is present. Okay. So for that, what we have to consider? From external memory to accumulator, we have an instruction. Already you people told, correct? Move X A comma at DPTR. Am I right? Can we use it as the first line in our program? Or else any other thing we have to do? What we have to do initially? Whenever you are going to access the external RAM memory content, the address must be provided in the DPTR register, correct? Because it is going to point the address from where I have to get the data or operand, correct? So first load in DPTR. What I have to load, Anthony Surya? Yes, very good. Move DPTR comma hash 8100. That's the answer I am expecting. Yes, move DPTR comma hash 8100H. Now what instruction I have to use? See, you people know very well, to perform arithmetic operation, we have to get one of the data to accumulator register, correct? Yes, move X A comma at DPTR. I have taken the data from the memory location 8100 to accumulator, which is nothing but the first operand organ, correct? I want to take the second operand. What I can do? What I can do? Any guess? See, first operand எடுக்கிறதுக்கு நம்ம already program எழுதியாச்சு. What about the lines we have to use to take the second operand from the external RAM memory? Any guess? Very good, Sajish. Okay, fine. So INC DPTR னு சஜீஷ் சொல்லியிருக்காரு. ஆண்டனி சூர்யா வந்து move DPTR, hash 8101 சொல்லியிருக்காங்க. Fine. So both are going to do the same thing, correct? What you people told, both of you told is correct only. I have to increment the content of DPTR by 1. It is going to be 8101, correct? Or else you can do move DPTR, hash 8101. What instruction I have to use after this? After initializing the DPTR again, what I have to do? First, argand எடுத்தாச்சு, add and point பண்ணிட்டு இருக்கீங்க. You have to take it from that location. Yes, Sivakumar, INC DPTR, okay. அதுக்கு அடுத்த லைன் என்ன வரும்னு கேக்குறேன். Any guess? After pointing to that memory location, I have to get the data. So which instruction I have to use? No, Sivakumar, it is not internal data transfer. Yes, Sivakumar is telling one point. Yes, sorry Sivakumar, your intention I can able to understand. Okay, Sivakumar typed move direct, A. Why move direct, A? Can you reply in chat, Sivakumar? Yes, Sajesh typed one answer, XCH A, B. Yes. Any other simple thing we can do? Yes. Very good, Danya. Move B, A. Okay. Move B, A. That's what I am going to do. First data நம்ம எடுத்து முடிச்ச உடனே நம்ம என்ன பண்றோம்? Accumulatorல இருந்து we are keeping the data to another register. Here we are preferring B register. Why I am preferring B register means when I am writing the multiplication or division program, obviously one of the data must present in B register, correct? So for that purpose I am using B register. You can also use R0 or R1, whatever register you have, or any memory location you have. That's your choice. It need not to be only B register. That point you have to understand. Somewhere I have to keep the first data. I have to free the accumulator. Accumulator free pannividum. Fine. Now, as Sajesh told, INC DPTR I have used. So now it is pointing to the memory location 8101. So from there I am getting the second data. Okay. What about the value X present? Argand in the register, add and in the register. The first operand what I have taken is Argand. It is available in B register. The second operand what I have taken is added, that is available in A register. Correct? Am I right? Okay, if I want to perform addition, which instruction I have to use? If I want to perform addition, which instruction I have to use? Add A, direct, add A, B. Fine. Okay, if I do this, how the addition takes place? Content of A plus content of B and gets stored into accumulator. Am I right? A register plus B register, correct? A register is having the second data Y, correct? B register is having the first data X. Here Y plus X is going to happen, correct? Whether it will affect the result, X plus Y பதிலா Y plus X நம்ம கண்டுபிடிச்சோம்னா result affect ஆகுமா? Definitely no. So directly we can go with the addition part, add A, B. So obviously we people know the result present in the accumulator. I want to store it in memory location 8102. Now DPTR is having 8101. What I have to do? Quick. For storing the result to the memory location 8102, what I have to do? The result is already available in accumulator. So what we have to do? We have to point the next memory in DPTR, I mean next RAM memory, correct? Shivakumar, இது எப்படி நம்ம எழுத முடியும்? Move 8102, A. It's not possible. We are speaking 8102 is the external RAM memory location. Correct? Obviously, we have to use MOVX. Correct? Before putting the data into the external RAM memory using MOVX, you have to initialize DPTR. Correct? Whenever you are doing external data transfer, you have to track on DPTR register whether it is pointing to that particular memory location or not. Yes, what about the next two lines? Result கொண்டு போய் DPTR point பண்ற மெமரில ஸ்டோர் பண்ணனும். Where I have to store 8102 ல ஸ்டோர் பண்ணனும். What about the instructions? Yes, very good suggest. Move DPTR comma hash 8102 movex at DPTR comma a. That is correct. I think Danya typed inc DPTR movex a comma movex at DPTR comma a. Both are going to be correct. Fine. So in the inc DPTR நம்ம யூஸ் பண்றோம். The reason is you can reduce 2 bytes. Move DPTR comma hash data அப்படினு சொன்னா 3 byte instruction. inc DPTR it is 1 byte instruction. Fine. So generally we used to prefer inc DPTR if I want to point the successive memory location. Fine. So that's all about the sum. Now I want to store the carry. Fine. For that what I can do? I have to store the carry. So carry irka illaya, carry base panni accumulator content 0 or 1 pananum. Yes, we have to clear accumulator. Yes, I have done because I have stored the sum. Correct. I don't need the result sum hereafter because it is stored in the external memory where we want to store. Correct. So I have cleared the accumulator. Next what we have to do? Yes, very good Shivakumar. ADDC A comma has 00. Very good. Okay, very good. Fine. Shivakumar typed the correct answer. But here I am going to introduce a new concept. என்ன அப்படினு பாத்தீங்கன்னா carry flag test பண்ணிட்டு நான் வந்து பண்ண போறேன். Fine. Before that I move the content, I move the result sum to the memory address 8102. I want to store the carry in the next memory. So I am incrementing the DPTR in between. இது எங்க வேணா நீங்க யூஸ் பண்ணலாம். After you have stored the sum into the memory location pointed by DPTR, immediately also you can use inc DPTR. Fine. Okay, now coming to this particular concept, here I am going to test the carry flag. Yes, carry illana I am telling skip அப்படினு நான் எங்க லேபிள் பண்ணிருக்கணும் அங்க போய் சொல்றோம். Suppose carry இருந்தா என்ன பண்ணனும் சார்? Suppose carry இருந்தா என்ன பண்ணனும்? accumulatorல இப்ப 00 இருக்கு. carry இருந்தா என்ன பண்ணனும்? Any idea? Yes, very good. inc A. What happened? carry இருந்தா ஆட்டோமேட்டிக்கா எனக்கு என்ன ஆயிடும்? A ரெஜிஸ்டர் 1 இன்கிரிமென்ட் ஆயிடும். கரெக்ட்? JNC return inc A. Very good Shivakumar. Very good. Fantastic. So these are the instruction I have to use. But one kind advice, ஜெனரலா நம்ம அந்த லேபிள் பண்றப்ப என்னோட நிமோனிக்ஸ் இருக்கு இல்லையா அதனுடைய கீவேர்ட்ஸ் வராம பாத்துக்கலாம். ஃபைன். Actually here we are having only RET, no issues. What Shivakumar typed is correct. So carry இல்லனா டைரக்ட்டா accumulator content DPTR point பண்ற மெமரில ஸ்டோர் பண்றோம். Suppose if I am having carry, I am incrementing accumulator. So carry இருந்தா accumulatorல 1 வந்துரும் இல்லனா 0 இருக்கும். So we are storing. So what about the last instruction to stop the program execution or to prevent the 8051 to execute further instructions? Yes, SJMP instruction we can use. So I am using the label stop. So the same instruction line I am labeling the name stop. Okay, that means infinite loop. Here we don't have any instruction to halt the program execution. So it is going to execute the loop again and again, infinite loop. Fine. So that's all about the program. Kindly take a screenshot. We will move to subtraction program. See, ஒரு program அப்படின்னு சொன்னோம்னா you are having a variety of logic. சின்ன விஷயம் கூட நம்ம என்ன பண்ணலாம் நிறைய மாத்தி எழுத முடியும். Yes. Shall I proceed to next slide? Yes, okay, fine. So subtraction of two 8-bit data using 8051 assembly language program, correct? ALP, fine. So here also we are considering the data is available in the external RAM. So here the operands are minune, subtrahend, x is going to be minune and y is going to be subtrahend. So we have to perform x minus y. Okay. So before that, x is present in 8300 and y is present in 8301. So I have to find x minus y and we have to store the difference and borrow in the external RAM memory location 8302 and 8303. So this is about the problem statement of the given program. Okay, fine. Kindly take a screenshot. I will move to next slide. I will move to next slide. Yes. Okay. So this is about the flow chart. The same logic. Take the minune, take the subtrahend, perform the subtraction operation, store the difference, store the carry. That's all. Okay. But the memory involved here is also internal RAM, sorry, external RAM memory. Fine. Okay. So ORG0000. So as here we have the data in 8300. What about the first instruction? About the first instruction, we have to initialize DPTR with the memory address from where we have to take the data. Correct? So what we have to do? Yes, move DPTR comma hash 8300. So we have to take the data, move x a comma t DPTR. I want to take another data which can also be coming to accumulator. So I am freeing the accumulator register by keeping the value in B register. Then I am pointing the next memory location in the RAM memory. So I am incrementing DPTR. I am taking the data. Okay. Now, what I have to do for subtraction operation? What about the instruction I have to use for subtraction? Yes, SUBB. So SUBB, one of the operand is accumulator, the other operand is B register. Okay, very good. SUBB A comma B. I want to ask you one question. Here, when I am performing subtraction with SUBB A comma B, what is going to happen? Content of A minus B will happen, or content of B minus A with borrow happen? Yes, A minus B will happen. Content of A minus content of B. Yes, yes. Y minus X will happen. Very good, Sajesh. I want to perform X minus Y. Y minus X is going to provide the negative result of X plus Y. So what I have to do? I want to make the content available in A to B and B to A. So what I have to do? Very good, super, fantastic suggestion. Yes, we have to use the exchange in of B. Now I am going to perform the subtraction. So now X minus Y will happen. To store the difference into the memory location, we have to point that memory location. So currently it is pointing to 8301. To point 8302, I am incrementing DPTR. Move the value from accumulator to memory pointed by DPTR. Okay, the same step. Clearing accumulator, INC DPTR. If no carry, what we have to do? Increment accumulator. Sorry, if no carry, we have to directly store the result. Else, we have to increment accumulator and we have to store. So here, borrow means it is going to reflect in the carry flag only. Fine. So that's all about the program. Kindly take a screenshot. Kindly you people take a screenshot. Yes. Shall we go into the multiplication program? If I completed the lab experiment earlier, we can have the unit test earlier. Okay, fine. Okay. So multiplication program for the same thing. Here the operands are multiplicand and multiplier. Multiplicand is available in 8400. Multiplier is available in 8401. We have to perform the multiplication of x and y. Obviously, when we are performing the multiplication of two 8-bit data, the result may be of 16-bit. So we are having two parts in the result. One is lower byte of the result, the other part is going to be higher byte of the result. Fine. I want to inform you one thing, why I am teaching this program. Okay, you peoples have to know how to access the data available in external RAM memory, because in some cases in your application the internal RAM memory may not be sufficient. I'm not surely saying, based upon your application. Okay, at that point of time we have to interface external RAM memory. Okay, so we have to know about how to access the external RAM. If time permits, I will also explain you how to perform the addition of two 8-bit data, which can also be stored along with your program in the program memory. Yeah, have you got it? உங்க program கூடவே உங்க data இந்த memoryல தான் இருக்கணும்னு சொல்லி நம்ம அதை என்ன பண்ண முடியும்? Assign பண்ணிட்டு we can also add the data from program memory also. Fine. So that part I will explain you if time permits. Fine. Okay. So here in this particular experiment, what we are going to do? The same thing, org, pointing to the memory from where we have to take the data. We are getting the value to accumulator. Then we are moving to B register. Then we are pointing the next memory location. We are getting. Fine. So now multiplier is available in B register and multiplicand it is going to be available in A register. Okay, what is going to happen? A multiplied with B or B multiplied with A? Any guess? The first data multiplicand is available in B register. Yes, multiplied it is available in accumulator. If you perform multiplication, what is going to happen? X star Y or Y star X? Kindly respond. Yes, Y star X will happen. Okay, whether it is going to affect your result? Multiplication of X by Y, same as multiplication of Y by X. So both are going to be same. So don't worry about the content of A and B. Fine. But one thing you must remember, addition subtraction la நம்ம first data வை எந்த மெமரிக்கு வேணாலும் மூவ் பண்ணலாம், இல்ல எந்த ரெஜிஸ்டருக்கு வேணாலும் மூவ் பண்ணலாம். But when coming to multiplication, one of the operand must present in accumulator, the other definitely it must present in B register. Okay, fine. So we have to use the instruction mul AB. Fine. So where the lower byte of the result will get stored? Because I want to store the lower byte to the external RAM memory. Fine. Yes, lower byte occurs in accumulator register. So I want to put the content available in accumulator to 8402. Currently DPTR is pointing 8401. So we have to increment DPTR. Then we have to put the value pointed by DPTR from accumulator. Correct? Fine. So you people type the next lines. To store the higher byte of the result in 8403, what are the lines I have to write? என்னென்னலாம் பண்ணணும்? First of all, B register content நான் என்ன பண்ண முடியாது, external data memory போட முடியாது. From B register directly. So what you have to do? The B register content can be transferred to or must be transferred to accumulator. Very good suggestion. Move A comma B, then INC DPTR, then move X at DPTR comma A. Very good. I think only few people are replying. Okay, I hope. I'm happy at least few people are replying. Yes. Move A comma B, INC DPTR, move X at DPTR comma A. Finally, the instruction. Okay. Now I am going to show you the multiplication program problem statement. You peoples are going to post the answer in the chat. Fine. I will verify it. So shall we go with the division program? Sorry, division program ku na problem statement na explore பண்றேன். Program நீங்களே சொல்லுங்க பாருங்க. Yes? Yes? Okay, fine. So division of two 8-bit data, one is available in 8500, the other is going to available in 8501. dividend divisor. Okay, the numerator number or the first operand is going to be dividend. The denominator operand or the number which is going to be a divisor, that we call it as y, is available in 8501. Okay, so I have to perform x by y and I have to store the result quotient and remainder in 8502, 8503 respectively. Okay, I will wait for your answer. Okay, kindly you people type the entire program in the chat. Yes, all of you try. I will wait. I will show the flow chart also. So this is about the flow chart we have to follow to perform the division operation. Entire program நீங்க type பண்ணிட்டு எனக்கு chatல post பண்ணுங்க. What about the result we will be getting that you people will post. Waiting for your reply. Okay, once you people post, I will go with it. I will give you enough time. You will try. Okay. Once you people find the answer, I mean program, you will go with the simulator software. Till you people are trying, I think so. Yes, I think Sajesh posted the result. Yes, I will verify your program, Sajesh. Yes, the program what Sajesh typed is correct. I think he missed one line. He indicated that. Okay, what about in classroom 1? Yes. இது ரொம்ப ஈஸியான ப்ரோக்ராம் தானே. See, why you people are taking this much time? Okay, you take your time, but provide me the answer. Whether you people try or I will post the answer. Yes, fine. Someone posted. Yes, Anthony Surya. Okay. We'll go with your answer. Fine. I think Anthony Surya, you have to include one more line in your program. Kindly check. Whatever you have typed is correct. One more line you have to include in your program. I'll check with Lotus Nega answer. Yes, you have to also include one more line, Lotus Nega. Kindly check. what you have done is correct, but you have to include line. Otherwise, your result is going to be different. Yes, yes, very good, Danya. Very good. Super. Dixon, you made one mistake. Kindly check. One of your line of the program, it will change the dividend and divisor. Both are going to be same. Kindly check. Yes, yes. Very good. Fine. So the answer provided by Sajish, Danya are correct. Fine. Anthony Surya, she given the answer, but in her program, y by x happened instead of x by y. So we have taken the first operand, dividend. It is available in B register. Divisor, it is available in A register. We have to swap the data available in A and B. So obviously we have to do exchange before performing division. Yes. There in the case of multiplication, no issues. Fine. Y multiplied by x, it is same as x multiplied by y. But here in the case of division operation, x by y is not equal to y by x. Am I right? So kindly those people who missed out the instruction xch a comma b, kindly introduce it. That's all. Okay. So remaining and all the same only, like multiplication program. Render and instruction multiplication program la change panna porom. What are the two things? You have to introduce one instruction xch a comma b. Then for performing division, we are changing div ab. That's it. So that's all about all the programs. Yes. The things are clear. Nalu program me ellarku purinjida. Kindly type in chat yes or no. What about others? Regular reply பண்றவங்க மட்டும் தான் பண்றோம். மித்தவங்களுக்கு புரிஞ்சுதா இல்லையா? Yes. Classroom 2ல yes கூட டைப் பண்ண மாட்டோம். ஆன்சர் கேட்டா அதுவும் வர்றது இல்ல. புரிஞ்சுதான்னு கேட்டா அதுக்கும் பதில் சொல்றது இல்ல. What I have to take? கிளாஸ் கமிட்டி மீட்டிங்ல கிளாஸ் நல்லா எடுக்கிறாங்க புரியுதுன்னு சொல்றீங்க. பட் ஆனா வந்து கிளாஸ்ல கேட்கிறப்ப புரிஞ்சுதான்னு கேட்டா யாருமே ஆன்சர் பண்ண மாட்டாங்க. சித்திரமான உலகமா இருக்குது. எஸ் ஆர் நோ? கிளாஸ் ரூம் 2ல ஒரு 5 பேர் தான் ரெஸ்பாண்ட் பண்ணிருக்கீங்க. ஃபைன். அந்த 5 பேருக்கு மட்டும் அட்டெண்டன்ஸ் போட்டு மித்தவங்க எல்லாம் ஆப்சென்ட் பண்ணிடலாமா? ஓகே ஃபைன். Okay. So now we will go with the software. Which software we used when you people came to college for for writing the assembly language code and execute the results? Which software we have used? Regarding 8051 microcontroller and 8051 ALP, which software we used? என்ன சாஃப்ட்வேர் யூஸ் பண்ணோம்ப்பா? கிளாஸ் ரூம்லயும் அந்த சாஃப்ட்வேர் வந்து போஸ்ட் பண்ணிருக்கோம். ஓகே, வித் டெமான்ஸ்ட்ரேஷன் வீடியோ ஆல்சோ. எஸ், கேன் யூ பீப்புள் நேம் வாட் இஸ் த நேம் ஆஃப் த சாஃப்ட்வேர்? யாருமே ரிப்ளை பண்ண மாட்டீங்களே. மறந்து போச்சா எல்லாருக்குமே? You people are replying. Am I audible in both classes?
Yes, sir, you are audible.
Okay, okay, but they are not replying. Yes, fine. Okay. Yes, the symbol logo already பார்த்திருக்கோமா? காலேஜ் வந்தவங்க இதை பார்த்திருப்பாங்க கண்டிப்பா. இந்த பேர் கேள்விப்பட்ட மாதிரி இருக்கா? எஸ். போன வாரம் என்ன சாஃப்ட்வேர் யூஸ் பண்ணோம்? 8051. ரிகார்டிங் 8051 ஆண்ட்ராய்டு ஆப் நம்ம என்ன யூஸ் பண்ணோம்? Yes, the 8051 Simulator Pro. Fine. So far, என்னென்ன platform நம்ம யூஸ் பண்ணிருக்கோம் அப்படின்னு பார்த்தீங்கன்னா, regarding 8085, we have used the 8085 Simulator Ultimate, correct? 8085 Ultimate Simulator Pro, correct? Okay. Regarding 8051 Android app, we have used 8051 Simulator Pro. For desktop, those who are having laptop or desktop, you have to go with MCU 8051 ID. Okay. One thing you people must aware, you people can do project using this particular simulator software itself. Okay. You are having many virtual hardwares, so you can do some simple tasks. Shall we do like that? Shall we do like that? So that you can learn something in this semester. For confident கிடைக்கும் நமக்கு. Unfortunately, we are having online class only. Okay. Also, considering your money, hardware வாங்குறது இதெல்லாம் நமக்கு கஷ்டம், கரெக்டா? So you have a provision to simulate the hardware with the program for what we have written. Fine. Program and the hardware both we are going to do in the software itself. So it is going to be an easy thing only. Yes. If time permits, we will utilize some of the future classes, microprocessor class session. We will convert it into some explanation regarding the hardware. So previous class we படிச்சோம் இல்லீங்களா, keypad 7 segment எப்படி work ஆகுதுன்னு. Similarly, we will explore more things. You people have to connect the hardware in the particular software. Okay, MCU 8051 IDE, and you can write the program for that. You people can do. Yes. Can we do? See, எதுவா இருந்தாலும் நம்ம பசங்களை பொறுத்த வரைக்கும் என்ன தெரியுமா, ப்ராஜெக்ட் கம்பல்சரி அப்படின்னா பண்ணுவோம், கரெக்டா? சஜீஷ் மட்டும்தான் எஸ்ன்னு போட்டுக்காரு, ஆண்டனி சூர்யா எஸ்ன்னு போட்டுக்காங்க, ஃபைன். லோகஸ் நேகா, ஃபைன். What about others? Danya. See, I am not asking you to do project. I am asking with the hardware what we are having in the application MCU 8051 IDE, we can write some program, we can connect the hardware, we can learn something. See, without you people practicing program, you cannot able to understand. Fine. ஒரு complete system ஆவது நான் build பண்ணாதான் எனக்கு ஒரு strong idea கிடைக்கும். I think Maitreyan, you have did more project using Node MCU microcontroller. Okay, why can't you use MCU 8051 IDE software and you can do some other project? Yes, Maitreyan, are you there? Okay, definitely I am expecting project from you. Okay, fine. See, all of you try to do some simple thing. Project na பயங்கரமா இருக்குன்னா கிடையாதுப்பா. See, project na நம்மலாம் என்ன நினைக்கிறோம், ராக்கெட் விட்டாதான் அது ப்ராஜெக்ட்லாம் கிடையாது. ஃபைன். சிம்பிளா ஒரு எல்இடி பிளிங்கிங் பேட்டர்ன் கண்ட்ரோல் பண்றது, இல்லை ஒரு சுவிட்சை நான் ப்ரெஸ் பண்ணனா எனக்கு ஒரு ஆப்ரேஷன் இனிஷியேட் பண்றது, திஸ் அண்ட் ஆல் கோயிங் டு பி a simple project only. It's very easy only. ஆல்ரெடி லேப்ல வந்து நம்ம என்னென்னலாம் டீச் பண்ணியிருக்கோம், ஸ்விட்ச், ஓகே, ஆர்ஜிபி எல்இடி, ஃபைன். தென் பஸ்ஸர்லாம் இங்கே நமக்கு இதில் கிடையாது இந்த சிமுலேட்டர் சாஃப்ட்வேர்ல. ஓகே, பட் வி ஆர் ஹேவிங் 7 segment, மல்டிப்ளெக்ஸ் 7 segment, கீபேட், மேட்ரிக்ஸ் கீபேட் இருக்கு, எல்சிடி இருக்கு, fine. Some temperature sensor we are having. See, if you people show some interest, you can put it in your resume also, because it is known to you. You only did that. Confidently, you can face the interviewing person. Okay. I don't want to spend more time. Fine. I will go with the simulator. We have some demonstration. So now I am going to stop the presentation. I am going to present the entire screen now. Wait a minute. Yes, present now. Entire screen. Yes. Okay, I'll present in the second classroom also. Present now. Share screen. Yes, is it visible? The screen is visible in both classes. Yes, okay, fine. Now I'm going to open the software MC82 IDE. Okay, fine. The things are clearly visible to all of you. Wait a minute. I will have at least one classroom chat so that I can know whether I am presenting online or not. Yes, the software is clearly visible, or if you have any difficulty in seeing that, you tell. I will make it as full screen because you people have to unmute and answer for me. Visible, okay, fine. In this particular software, to create a project, which menu I have to select? மேலே வந்து இப்போ நமக்கு என்னென்ன மெனு தெரியுது? File, Project, Utilities, Configure, Help. All other things are added, correct? So which, yes, I have to click on Project. Once I had click on Project, what I have to click? What I have to click? New, because I'm going to have a new project, correct? So I'm going to click on New. I will get a pop-up window like this. I am going to type the name of experiment as 6A underscore addition. Don't use space. In the file create regarding an embedded system development, whatever the software you people are using, kindly use underscore. Okay, don't use space when naming the files or folders. Okay, then project I have to select. Okay, I'm going to select the documents. Okay, right click on the white space so that you can create a new folder. So I am going to create a new folder with ECE underscore ETE underscore 6A. Fine, this is the folder name I am going to create. Okay, so select the folder, then click on OK. You can see like this. See users, name of your computer, documents. See, you have to identify where your program is getting stored. Fine. The next thing, whatever the microcontroller we are going to use, you can choose. Here it is 8089S52. I am leaving as it is. Fine. Whether we are going to use external RAM memory or not. Are we going to use external RAM memory? Yes. Okay. So what I have to do? I have to enable the box external RAM memory X data. Okay, I am enabling external data. Enable paniyachi. Make the slide to reach its maximum position so that you can have 64 KB memory. Fine, but you can choose as much you want. But remember one thing, 8000 la data la kuduthukkom 8500 la. So appo ethnaal memory location namakku theriyadhu. So we are enabling all the memory location. Click on OK. So now a window will open. So here I am going to type our project code. Code type panna poren. So org 0000h move dptr comma hash 8100h move x a comma at dptr, then move a comma b, then inc dptr, then move x a comma at dptr, then add a comma b, then inc dptr, okay, then move x at dptr comma a, then clear accumulator content, find the next memory location, no carry and skip. Okay, skip the word it is a keyword related to this software, so I am going to use simply yes, JNC yes. If there is carry, I have to increment accumulator, or else we have to go to the line labeled as yes. So here we have to move the dptr comma a. So that's all about the program. So I have to stop the program execution. Stop sjmp. Okay. Generally, we have to use the command, assembler command end. So below this line, whatever you are typing, it won't be considered by your software. That's all. After I have entered the program, what I have to do? After I have entered the program, what I have to do? In the particular platform or seri, language or seri, one program first விஷயம் என்ன பண்ணுவீங்க? Yes. Program எழுதி முடிச்சோனே நம்ம yes, we have to save the program. Okay. So I'm going to click on file, save as. First time மட்டும் save as னு கொடுக்கலாம். Fine. So I am going to keep the name of this source code. So 6a edition. இது வரைக்கும் நீங்க கொடுத்த நேம் தான் இங்க கொடுக்கணும் கிடையாது. You can also use like this 6a sum அப்படினு கூட கொடுக்கலாம். Whatever you wish you can give. That's all. So it is asking you to whether you are going to add this particular source code to the project. Yes, that's all. So now our program got saved. So for debugging this particular program, what we have to do? Once you have saved the program, click on simulator. Here, which option I have to choose? Which option we have to use? What option use for the bar? Yes, debug this file only. I am clicking on it. So it is asking simulated data not found. Do you want to create it? Yes, that's all. Go to message and verify that the things are clear. Yes, compiling the file, initializing the preprocessor. There is no error or warning in the code. Correct? Zero error, zero warning. Compilation successful. Correct? Some other thing. Okay, now we have to provide the data for this program. Am I right? Am I right? When the program நம்ம வந்து டைப் பண்ணி எல்லாமே பண்ணியாச்சு, அடுத்து என்ன பண்ணணும்? About the next step we have to follow. We have to provide the data. Fine. So for that, what we have to do is click on virtual MCU. Click on virtual MCU. இதுல first thing நம்ம enter பண்ண இந்த program வந்து code memory ல தான் ஸ்டோர் ஆயிருக்கும். கரெக்ட்டா? That you people can see it up. தெரியுதா? 90 is the output for move dptr comma data 16. The data is 8100. 85 ல எப்படி நம்ம assemble பண்ணோம்? 8085 ல lower byte then higher byte. இங்க எப்படி பண்றோம்? Higher byte then lower byte when it is a data. Fine. No need to worry about this. Your software is generated the output for your program. Fine. Now I am going to close it off. Okay. Similarly, I have to enter the data. Data input நம்ம எங்க கொடுக்கணும்? Which memory the data should be present? Which memory we have to prefer? 8100. What about the memory? Either it is internal RAM or internal ROM or external RAM or external ROM. data எங்க இருக்கும்பா RAM memory தான் இருக்கும் external RAM correct so X data memory that is going to be external memory fine I am clicking on it இங்க நம்ம ஒவ்வொரு அட்ரஸா தேடி போக முடியாது அதனால என்ன பண்ணலாம் கீழ பாருங்க அட்ரஸ்னு கொடுத்திருக்காங்களா we are generally representing the address in hexadecimal format okay so 8100 type பண்ணிட்டு first data we can give what about the first data என்ன data கொடுக்கலாம் you people suggest me data I will make use of it yes 16 it is hexadecimal number don't forget okay the next memory location 8101 la I have to give another data about the next data okay I think Sivakumar typed 67 Danya typed 55 okay first Sivakumar type பண்ணதனால I am giving the data as 67 hexadecimal fine okay can you find the answer for this 16 plus 67 what about the result we can get both are hexadecimal number don't forget kindly find the answer and tell me 16 plus 67 6 plus 7 equal to what first you add the lower digit see bitwise நீங்க எழுதி add பண்ணா டைம் ஆகும் அதுக்காக நான் இந்த மெத்தட் சொல்றேன் 6 plus 7 is equal to what 6 plus 7 என்னப்பா decimal la what is the value of 6 plus 7 13 what is the hexadecimal equivalent for that 13 yes very good Shivakumar 7D is the answer I am expecting so for lower digit add பண்ணா D அடுத்து higher nibble 1 plus 6 add பண்ணீங்கன்னா 7 direct ஆவும் பண்ண முடியும் so 7D is the expected answer shall we run the program and verify the result so to run the program what I have to do click on simulator which one I have to click step by step பண்ண போறீங்களா இல்ல full execution பண்ண போறீங்களா that you people have to decide எதை யூஸ் பண்ணலாம் full execution பண்ணிடலாமா இல்ல step by step போலாமா step by step okay fine so அதுக்கான keyword பாத்துக்கோங்க F9 shortcut இது சரிங்களா first type sorry F9 கிடையாது F7 okay or else you can use this footprint button இத click பண்ணாலும் step by step நடக்கும் நல்லா கவனிங்க இங்க நமக்கு ரெண்டு DPTR இருக்கு as we choose the 8052 correct இங்க நம்ம choose பண்ண மைக்ரோ கண்ட்ரோலர் என்னது 8089S52 so இங்க வந்து நமக்கு ரெண்டு DPTR இருக்கு வெயிட் பண்ணி பார்க்கலாம் where the DPTR is available I think still I have to go so here we are having accumulator B register yes here we can see DPTR 0 DPTR 1 fine first DPTR la enna irukku parunga here when I mention DPTR it represents DPTR 0 only okay fine I am going to click on the step icon what happened DPTR la enna value irukku what is the value available in DPTR what's the value now available in DPTR you people can see this yes 8100 combinedly DPTR is having what value DPH la 81 irukku DPL la 00 irukku so what we are having you can see I think hexadecimal value மட்டும் பாருங்க 8100 yes kindly respond தெரியுதா இல்லையாப்பா இந்த இதுல சிமுலேட்டர்ல are you people seeing no response yes only Logus Nega replied yes fine okay now I am going to execute the next instruction what about the purpose of next instruction Shivakumar movex a DPTR 8100 la enna value irundhuchu first data yaar சொன்னீங்க 16 சொன்னீங்க கரெக்ட்டா yes இப்போ accumulator என்ன இருக்கு பாருங்க 00 when I am going to execute the next instruction it is getting into the accumulator register am I right Yes, here you can see 16. Correct? Fine. Next, move A comma B. Here I think I made a mistake. Sorry. Code or mistake பண்ணிருக்கோம் அது யாருமே சொல்லலையே. Here I have to use move B comma A. Sorry. Move B comma A. I'm sorry. So I am going to save the program once again. So now I am going to click on simulator, debug this file. Yes. Okay, once it is done, first step 8100, next step 16. So now, what about the content available in B register? 00. After executing the instruction move B comma A, B register is also having the data 16. Okay. Now increment DPTR. Yes, DPTR become 8101. Correct? 8101. Now I am getting the second data to accumulator. What about the second data? 67. Correct? Yes. Yeah, 67 on the chair. Add A comma B. Result will get stored in accumulator 7D. Correct? So I am pointing the next memory location. Increment DPTR பண்ணியாச்சு. We have to put the content in where? 8102. நடக்குதான்னு பாப்போமா? Fine. First I am going to execute. அதுக்கு முன்னாடி பார்த்தலாம். External memory 8102 ல 00 தான் இருக்கு. Fine. After execution, after I executed that particular instruction, you can see now. So what is available here? About the data we are having 7D. Correct? Similarly, we can go with other steps. So clear accumulator, accumulator becomes 0, INC DPTR, so 8103. Now we can check C flag. Red color la irundha reset na artham, green color la irundha set na artham. Now it is reset. So condition is true. So here it is going to skip INCA instruction. Correct? I think I have executed the entire program. Okay, sorry. Simulator, click on step. Yes. Over step up. Yes. After executing, JNC directly goes to which line? MoveX up to DPTR comma A. That means it is going to store the carry also. So after that, if you execute the same line, it is executing again and again. So that's all about the result. 7D is the sum and 00, there is no carry. Fine. Okay. So immediately I am going to change this program as subtraction and I will run. Okay. Wait for some time. I will give some simple data so that you people can understand. So adula memory location enna sollirundhompa subtraction ku I told 8300. Correct? So everything is same. Inga nama subtraction pandradhukku munadi enna pannanum sonnom. Before performing subtraction, what we have to do? XCH A comma B. That's very important. Then we have to type SUBB. ரெண்டே change தான் பண்ணிருக்கேன். I'm going to save the program. I have saved. So now I am going to debug this file. Yes. Okay. Now where I have to give the data? 8300. Correct? 8300. I am going to give simple data only. So I am going to give it as 9. Okay. The next memory location 8301. I am going to give the data as 4. So what about the result I have to get? After executing this particular program, what about the result I have to get? 9 minus I have to get 5. Am I right? Okay. So now what I have to do is I am going to run the entire program. So click on run. Program is executing. You people can see the result. Wait a minute. I have to stop this program execution so that I can see the result. Yes, 9 minus 4 is going to be 5. There is no bar. So that's all about the use of this particular app. Fine. Suppose if I change the data as like this, 8300 la 9 போட்டுட்டு sorry 4 போட்டுட்டு suppose if I am giving the data in 3301 as 9, what will happen? Borrow will happen. Okay. So just what I am going to do is debug this file. Enter. Run. Program running இருக்கிறப்ப நமக்கு output பார்க்க முடியாது. So we have to stop. We have to check the result. What about the result we are having? FB01. FB is the difference and 01 is the borrow. It represents the borrow. Okay. I think time is around 3:18. Okay. Now I will project the question paper. So with this, I am going to stop the recording. You people stay with your material. You have to stay in the Google Meet. I mean this particular session till you people upload your answer. Okay. Now I am going to present the question paper now. Stop presenting now. I am going to stop the recording also.